Friends, we are going to discuss today the effect of temperature and pressure of steam on steam turbine and thus power plant systems. Before going to discuss the steam temperature effect of steam temperature and pressure on steam turbine, we are going to discuss some cycle which we are going to use normally in for determining the thermal efficiency of the system. This is called the ranking cycle. This is the ranking cycle is a model used to predict the performance of steam turbine system. It is an idealized cycle in which friction losses in each of the four components are neglected. And third is the heat is supplied externally to a closed loop which usually uses water as the working fluid. If you see the diagram here, this is the boiler feed water pump. Here we are adding some energy. Then it is going to high pressure and high pressure boiler water is going to the boiler. Here also we are going to give this energy through this coal or anything or coils. Then this high pressure steam we are expanding the turbine. Here we are getting some energy, and then finally it is going to the condenser. Here the latent heat of the steam is we are losing. It is going to sink. It is going to sink. This total system is called the power plant system. Then if you see the T and S diagram, if you see 1 to 2 is the boiler feed water pump where we are increasing the pressure. From 2 to 3 it is heat is we are giving water becomes steam, then disaturated steam here 50 kg bar, and then here it is expanding, and then up to 4, and then it is going to condenser, and condenser up to 4 to 1 is condenser. So here this is the TS diagram of the boiler system. Boiler system 3 to 4 is the disaturated vapor which is expanded in a turbine and generating some power. Next is how to improve the thermal efficiency of the turbine. Now we can improve the efficiency of the turbine by increasing the average temperature at which the heat is added to the cycle, or by decreasing the average temperature at which heat is rejected to the cycle from the cycle, by increasing the superheating temperature of the steam, by increasing the maximum pressure of the steam, by reducing the exhaust pressure of the steam, by regenerative feed heating, by reheating this steam, or combination of all this system. So all this process explained here, and that will increase the efficiency of the turbine. Now first we'll discuss the efficiency increased by increasing the superheat. Suppose earlier it was here up to disaturated steam, but we are increasing it to up to from 1 to 1 dash, that is supersaturated steam, and expanding the turbine. So this much extra work we are getting, but this much the steam, this much the heat we are rejecting in the condenser. But as this getting area work done is more than the heat rejection, so thermal efficiency of the thermal of the turbine will increase, system will increase. Now maximum pressure. Earlier the pressure was from 3 to 4, and the disaturated steam again superheat up to 1 and then expand. So this one work done, the hatch portion we are work done we are earlier getting. This is the heat rejection LM to 2 dash. Now we are increasing the pressure up to 4 to 4 dash, and that you see this one, and then again heat to the same temperature 1 dash. So this is the additional horizontal hatch line is the additional work we are getting. But this additional work in present condition with high pressure and earlier condition with low pressure more or less same. But as the heat rejection, you see the heat rejection, the earlier case it is 2 dash LM, each 2 LM, which is less, is more than the heat rejection here. Earlier heat rejection was here. Earlier this rejection is this. So this much heat rejection will not be there in the when you are increasing the pressure. So your efficiency of the system will increase. Now reheating of the ranking cycle. Reheating means we are taking boiler, we are increasing the temperature. From increasing temperature, high pressure, high temperature steam is going to the turbine. After some expansion, we are taking the some bleach steam and total bleach steam and giving it again to the boiler, and again reheating in the boiler. We are using it in the MP turbine, medium pressure turbine, and expand it to the and then condenser. So you see, first we are increasing the pressure up to 1 and temperature, then expand it up to the disaturated steam. Then again we are taking the full steam from here, full steam. Again in the boiler we are increasing the temperature up to the same level, more or less same level, same temperature, and again we are expanding. So we are getting additional work here. You see, this is the hatch portion. This is the additional work we are getting. But at this area, and this is the this portion 4, and this portion is a heat rejection. But as the getting work done is more than the heat rejection, so overall efficiency will certainly increase if we reheat the extraction stream to the and enter it in the MP section of the turbine. So efficiency will increase. Now, regenerative feed heating. You see, after boiler, high pressure, high temperature will expand in the turbine, and we are taking some steam from the boiler. Rest of the steam is going to the condenser, rest right of the same remaining portion of the turbine and going to condenser. But we are taking some extraction out from the turbine, and then we are heating this steam we are using for heating the feed water, boiler feed water. So earlier temperature was less. Then after heating, we are getting more temperature. So naturally, the system temperature, system efficiency will increase, because here when we are allowing steam to directly to condenser, here we are latent heat we are losing in the condenser. Huge amount, around 440 kilocalorie per ton per kg of steam we are losing in the condenser. But here, when we are taking extraction, the latent heat also we are utilized for feed heating of the boiler. Feed heating of the boiler feed water. So that's why though overall capacity may come down because we are taking some extraction. So less steam is going from to the remaining portion of the turbine, but efficiency of the system will increase because here we are losing some latent heat, huge amount of latent heat, but here we are utilizing the latent heat of the steam and increasing the boiler feed water temperature. That's why the efficiency of the system will increase. Now exhaust pressure. Earlier exhaust pressure P2, P2, and now the exhaust pressure has bring down to P2 dash. P2 dash. So this is the additional work done we are getting. We are the red color, the hatches portion, with the additional work done we are getting. Instead of the additional work done we are getting, we have to give some heat here. You see LM 4.43 ml. This is the additional heat we are giving. But instead, while giving the additional heat, we are getting more work done here. That is 4.4 2 P2. This is the additional work we are getting, and less heat we are giving here. That's why efficiency of the system will increase. Efficiency of the system will increase. Now you see the effect of steam pressure. Effect of steam pressure. Suppose earlier temperature boiler in turbine entry pressure was 35. Now, if we increase the temperature pressure of 45 bar kg per centimeter square, then you see earlier when the pressure was 35, its steam consumption was more, 99.9%. But when you are increasing the pressure up to 45, its steam consumption has come down to 97.8%. So 2 point something per 2%, around 2% steam consumption will come down if we increase the pressure from 35 to 45. Similarly, for 30 to 35 kg increase pressure, similar pressure, you see the efficiency. Earlier efficiency was how much? 32.1, 33.1. Now for 45 pressure, efficiency will increase to around 34.2. That means around 1.2% or 1.1% efficiency increase will take place if we increase the steam pressure. Similarly, if we increase the steam temperature, you see earlier temperature was 300 degrees centigrade, now temperature have increased to 400 degrees centigrade. The steam consumption earlier was 400 degrees centigrade, only 88%, 88 to steam consumption. Earlier when we were running with 300 degrees centigrade, steam consumption was 100. So 12% steam consumption, specific steam consumption has come down when you increase the temperature. Similarly, if you increase the same temperature, if you see the thermal efficiency, earlier efficiency at 300 degrees centigrade it is 33.1, and now 400 centigrade efficiency was 34.3. So around 1.2% efficiency increase was there. Now exhaust pressure, if you see earlier exhaust pressure was 0.13, now you bring down the exhaust pressure to 0.04. Earlier, when exhaust pressure was 0.13, each steam consumption was 100%, and then you bring down the exhaust pressure 0.04, so steam consumption has come down to 92%. That means around 8% steam consumption has come down when you decrease the pressure. Similarly, for decreasing the pressure 0.13 to 0.04 efficiency, if you see earlier efficiency for 0.13 exhaust pressure, efficiency was around 32.5, and now efficiency has increased due to lower pressure 34.8, around 1.2% efficiency increase was there due to bring down the lower back pressure bring down the back pressure. So friends, I think I have covered all the parameters, effect of all the parameters, temperature and pressure on turbines. I think if you go through these slides, your concept will clear. If you still have any question, you can ask me, give me feedback and ask me questions in my mobile number or my email ID. I will be very happy to reply you. But these are the very important thing. You may be asked in your interview board: effect of temperature, pressure, regeneration, reheating. Certainly, I think if you go through these topics, you will be able to reply it nicely. Thank you very much.